Alrighty, folks, we are going to start off by taking a look at our DMR. We did pretty well. There were a few that we needed to take a look at, so we're going to review those together, okay? All right, first thing, our word problems. Remember, as Steve pointed out for us yesterday, word problems means we need words in our answers, and if we have a complete sentence in our questions, we should have a complete sentence answer, okay? Mara wants to give 4 of her friends some Beanie Babies. She has 12 Beanie Babies that she wants to give away. So we've got 12 Beanie Babies. She's got 4 friends. Friend 1, friend 2, friend 3, friend 4, and we'll give her friend some arms, I guess. There we go. All right, there we go. So now she's got friends, okay? How many Beanie Babies will each friend get if she gives them the same amount? When I solve this, I can give 1 Beanie Baby to this friend, 1 to this friend, 1 to this friend, 1 to that friend. That's 4. 5, 6, 7, 8, 9, 10, 11, 12. And each friend got a group of 3 Beanie Babies. So this was a division equation. 12 Beanie Babies divided by 4 friends gives us 3 Beanie Babies per person. So that would tell us here that Mara will give each of them 4 Beanie Babies. Wrong, because they got 3. Each friend will get 8 Beanie Babies. Wrong, they got 3. Each friend will get 3 Beanie Babies. Yes. Mara changed her mind and wants to keep all of her Beanie Babies. Boo. Okay, each one got 3. What questions can I answer about that? About this question only. I'm going to lower hands because that's not about this question. Yes, Steve.
I just noticed, and I was actually having a hard time with this. The correct answer wasn't a story answer.
What do you mean?
I mean, it wasn't a complete sentence.
It is a complete sentence. It has a subject, a verb, and a noun. Each person gets 3 Beanie Babies. All right. Terrence, a question about this problem.
What are Beanie Babies?
Oh, my heart. Beanie Babies were my generation's plushies. Don't giggle at me. All right, here we go. This one, we did well, but we missed the oh. Y'all keep telling me you know, but then you miss it. And remember right up here, I told you it's going to tell you how many you should choose. Look, there are 3. You should have chosen 3 for this one, okay? This has 1, 2, 3, 4 parts. So our denominator is a 4. 3 of the parts are shaded. So this fraction is 3/4. This fraction does not have thirds, so the first 2 answers are gone. This fraction is more than half. Here's half of the circle, and we have more of it over here. So more than half is an answer that you should have selected. You also should have selected that this is 1/4 plus this 1/4 plus this 1/4. So that is 3 1/4 pieces, okay? This up here gives you a little hint telling you how many there are. All right. Any other questions? Make sure you answer all. 11, a question?
On one of them. Wait, oh, this isn't the right one.
Gotcha. Let me know when you're ready. All right, here we go. Next up, we did well on this. We got our correct answer. 8 plus 9 is 17. Carry my 10, put down my 7 ones. 110 plus 110 is 2 10s. Plus 8 10s is 10 10s, which is 100 and 0 10s. 400s plus 100s is 500s, so you should have selected 507. All right. Next up, we know that the answer to an addition equation is a sum. Next up, we have fractions. We can see by looking at these fractions that this piece is clearly bigger. This piece is 1/4. This piece is 3, 6, 9, 1/9. We know in fractions, the bigger the denominator, the smaller the piece. The smaller the denominator, the bigger the piece. So 1/9 is less than 1/4. Okay. All right. Next up, same thing, kiddos. It says all that are true. And notice right here, I gave you a little hint. This has 3 correct answers. So you've got to choose 3 correct answers to get your points. 11, is this one you have a question on?
Yes, my mom didn't believe me. She thought each one would count as 3 points, and I told her I'm supposed to do 3.
You
And
would,
she wanted that,
yes, you would think that that's how it would work, but for some reason, Google doesn't want to work that way. But I'm going to give you those points. So if you get 2 out of 3 on your test on Friday, I'll add those 2 points into your score, but Google won't, but I will. Okay. I love you more than Google, I guess is what we can take away from this. William.
The last answer, 90 tens, it was hard because it didn't sound right.
I know. We'll take a look at it. All right. 908. There are more hundreds than ones. There are 9 hundreds. There are 8 ones. 9 is more than 8. That is correct. The expanded form of this number is 900. Yep. Plus 10. No. There are 0 tens. The word form of this number is 980. No. That T at the end makes it wrong. This equals 9 hundreds and 8 ones. Yes. There are 90 tens in this number. That is correct. So if you look right here, this is 90. And we know that 10 tens equals 100. So 9 tens equals 900. You can also think of this about money. Okay, if I were to have 90 $10 bills, I would have $900. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20. We would keep going until we got to 90 tens, and that would give us 900. Okay. Terrence.
I did that and it said it was wrong.
Well, then you didn't do all of it because there's no other way. Nope. It's technology. There's no way to argue with it. It is what it is. All right, folks, that's your DMR. You will have your other released today. For now, let's get to our math lesson on comparing fractions. And guess what, y'all? We all mixed up. All right, I'm going to invite some of my friends to put their cameras back on. Camille, camera on. Awesome. All righty, here we go. All mixed up. With your teacher, we're going to watch a teaching video on slide 1. We are going to add a response and complete slide 3 together. And we will do slide 4 in a breakout room. And slides 5 and 6 will be completed with us as well. Then you will be independently working on slides 7 through 13. Okay? All right. On that add response button, here is our success criteria for the day. Please listen and consider your goal.
Before today, we have been looking at fractions that just have the same denominator and also looking at fractions that have the same numerator. Today, we are going to mix it up and we will be working both with fractions that have the same denominator and fractions that have the same numerator. We will be looking to make sure that you can justify the conclusions based on your realization if they have the same numerator or same denominator. We will be using our vocabulary to justify comparing to the whole number, using the words denominator, numerator, and fraction, and making sure that we have a good understanding of these vocabulary words to help us sort and compare fractions today.
All right, so those vocabulary words are what I should be hearing in explanations. It is bigger is no longer a choice, okay? You need to be using words such as greater or denominator is greater and so on, okay? All righty, Braden, I put something in that chat. I want you to answer, please. All right, this says we're going to watch this video. We're going to stop at 317. So we're not going to watch the full thing, but this is comparing numerators. We're still a little bit confused.
Hi, this is Yvonne from
This is going to help us get it together.
Kiwi Math, and this video is about the strategies for comparing fractions that are used in 3rd grade. And this is what is actually built upon in 4th grade. So 4th graders need to know these strategies plus more, but we're just focusing on the 3rd grade strategies. So the first strategy is called common denominators, and we use this strategy when we have two fractions that have the same denominator. In this case, the denominator is 6. And in order for us to figure out what's more, 4/6 or 2/6, we have to think about what the denominator actually means. So if we take a look at both of the wholes that we're talking about, right? The whole for 4/6 and the whole for 2/6. Both of these wholes are cut into 6 pieces, 6 equal pieces, which means that the sizes of the pieces in each whole are the same. And that's what our denominator means. It actually tells us the size of the piece. So if both wholes are cut into 6 pieces, then we have to take a look at the numerator. And what does the numerator actually tell us? It tells us the number of pieces that we're looking at. So in the case of 4/6, we're looking at 4 pieces that are the size of 6. In the case of 2/6, we're looking at 2 pieces that are the size of 6. And therefore, you could see visually that the 4/6 is greater. And if we think about that conceptually, if we think about the denominator being the size of the pieces, then anytime there's a common denominator, the greater numerator, which is the greater number of pieces, is going to be greater. Let's take a look at our second strategy. This one is called common numerators. And this would be used when we have two fractions that have the same numerator. So in this case, the numerator is 4. And again, let's reiterate from before that the number of pieces is what the numerator means. So this means that we have 4 pieces that are the size of 6 and 4 pieces that are the size of 8. So if we have the same number of pieces, if I have 4 pieces and you have 4 pieces, which one is greater? And in order to answer that, we have to look at the denominator, which tells us the size of the pieces. So let's just take a look at what 6 would look like. This is our whole, and it's cut into 6 equal pieces. And now we're going to take the same exact size whole, and we're going to cut it into 8 equal pieces. And what you could see is that one piece that's the size of 6 is greater than one piece that's the size of an 1/8. And why is that? If we're taking the same size whole and we're splitting it into more pieces, each of those pieces is going to be smaller. Therefore, if you have a greater denominator, each piece is going to be smaller. So if we know that one piece that's a 1/6 is greater than one piece that's an 1/8, then if we have 4 pieces of each, you could clearly see that 4/6 is greater than 4/8. So again, we want to think about the number of pieces that we have is the same. So what's different is the size of the pieces, and the fraction with the smaller denominator gives us the bigger size pieces, and therefore that's the greater fraction. Our last strategy.
All right. So we have taken a look at common numerators and common denominators as strategies. I still have some of my gremlins telling me that 4/8 is bigger than 4/4 because 8 is a bigger number. No, we know that the bigger the denominator, that means you have to share it with more people. It means you get less, okay? Less pieces, less size of a piece, all right? Okay, let's take a look at slide 3. Slide 3 says, with your teacher. We have a question, which ones go together? Okay, which ones go together? I would like for you to use numerator, denominator, unit fraction, greater than, less than, and fraction to answer the questions. Okay, so ideas, which ones of these go together? What do you notice? What do you think matches here? What go together? Any thoughts? Christopher?
I say the 2/5 with the picture go together because the denominator and numerator. Wait, no.
I think you're onto something. Take a look. 2/5 of this are not shaded. I can see that. Okay, so we have 2/5 that are not shaded and 2/5 here. Okay, Christopher says the picture with fifths and the numerator 2/5 go together. Other thoughts or ideas? What go together? Leah?
That the numerator and denominator is the same as the 1/3.
1/3. So right here, you're seeing that the 1/3 not shaded can connect to this one right here, okay? Aiden G, do you see connections?
Yes, because it says a 5 and it's 5 pieces on each and 3 pieces on the other one.
So this goes together because it has a denominator of 5 and there are 5 pieces. And this one goes together because it has a denominator of 3 and there are 3 pieces. So this has the same denominator and this has the same denominator. Okay, very good. I also see a connection here that this has a numerator of 2 and this has a numerator of 2 pieces shaded. Lots of connections here, lots of different ways to put these together. Aiden Hampton, do you see another? Can't hear you, Aiden.
Okay. I see a connection where there's 2 shaded in, and there is a number 2 right there.
Yep.
And I see a connection.
Hold on. You said a number. What vocabulary word is this? What is this called? The top number of a fraction.
That number is called 2.
That is a 2. What is that? What?
Oh, numerator.
Yes, numerator. Good. So it's got a 2 numerator, and that connects to the 2 pieces shaded. Awesome. Thank you. Oscar, what connection do you see?
I see the ones like the ones those 3 shaded in. No, not that. Yeah, that one and the denominator of the other one has 3 too.
Yes, so there are 3 pieces here in the denominator. There are 3 pieces on our total fraction. Wonderful. William, last connection.
I see that over here on the left side that the denominator has 3 left. So my connection is the denominator over here is 3, and then that denominator has 3 left.
All right, so this would be a numerator of 3/5, but that denominator over there of 3 is a connection as well. Very good. All right, you're getting ready to go into your breakout room. In your breakout room, you are going to share connections that you see on slide 4, okay? So talk about the connections with your group. Tell what you notice, what is connected, what is the same, and I will hear from you when you get.
I said that.
Here we go, getting learned. Here is what you should have figured out based on the focus of our lesson. The top two have the same denominator. This is 3/4. This is 4/4. They have the same denominator. These should have been connected by the same numerator. This is 2/2. This is 2/5. Same denominator, same numerator. All right.
Some of y'all.
You get learned. It's one of my favorite comedians. You're going to learn today. All right, we got it right there. Okay, so same numerator, same denominator. Those are our connections. You do not need to write that down. This was just a mental exercise. All right, head over to slide 5, please. Slide 5, 5, 5, 5, 5, 5, 5, 5.
I'm like one of them people that
Parents, I
say
need
it
you
over.
to chill, please. I am teaching. Thank you. All righty, slide 5. Here we go. We have directions. The directions are in this little video. Let us listen. No, pause. I don't want to watch that video yet. That's the answers in case you're asynchronous. The answers are down here. These fractions all have the blank size unit fraction. These fractions all have the blank size unit fraction. We're going to fill in the answer there. Okay, let's work on this together. If you're asynchronous, you can watch this video. All right, same numerator, same denominator. Let's look right here. 1/2, 1/6. Is that the same numerator, same denominator? Let's do it this way. If it's the same numerator, put your hand up top. If it's the same denominator, put your hand on the bottom of your camera. Same numerator, same denominator. Where's it at? Numerator, denominator. Yes, on top, same numerator. Slide that over. The number up top, 1/2, 1/6. All right, next one. 2/4 and 4/4. Same numerator, same denominator. 2/4, 4/4. Numerator, denominator. Show me with your hands. Thank you, Leah. Thank you, Terrence. Thank you, Levin. People, you have been given a direction. Show me with your hand. Is this the same numerator up top on your camera? Same denominator on bottom of your camera? Show me, show me, show me. Very good. Denominator. Don't make each one take that long. Good Lord, people. Next one, 2/5 and 2/6. Same numerator, same denominator. Where's it at? Is it the numerator up top that's the same, the denominator down bottom? Thank you. Same numerator. Very good. That top number is the same. 1/8 and 5/8. 1/8, 5/8. Same numerator, same denominator. Down low. That's right. That denominator is the same. So they have the same size piece. 3/6 and 1/6. Same numerator, same denominator. Show me, show me. Some of y'all are putting it on your nose. Your nose is the middle. Where's it at? Same numerator up top, same denominator down low. Get low. That's right. Same denominator down bottom. 6/7 and 6/8. 11 gave me a salute right away. That's right. Same numerator. Okay. Now that we've got these sorted, let's think about what they mean. It is helpful for us to figure out if the numerators or denominators are the same, because that tells us something about the unit fraction or the size of the piece. Okay. If fractions have the same numerator, they have a different denominator. 1/2 and 1/6. Those are different sized unit pieces. So let's add that on there with the text box. These fractions all have different size unit pieces. Okay. These are going to be differently sized unit fraction pieces. So that means we can think about which one is going to be a bigger piece and compare them that way. Camille, camera on. Okay. Now we're looking at same denominator. When fractions have the same denominator, 2/4, 4/4, 1/8, 5/8, 3/6, 1/6. When they have the same denominator, they have the same sized unit fraction. So when we compare, we can just think about how many of them there are. So when fractions have the same size unit fraction, we just have to think about which one has more. When they have a different unit fraction, we have to think about which piece is bigger. Okay? Questions about any of that? Yes, Terrence.
It won't let me go to my Zoom.
I am sorry. I'm having technical difficulties over there today, kiddo. Alrighty, let's take a look at slide 6. This is the last slide that we're going to look at together. This says vocabulary. As a reminder, we need to be using the words numerator, denominator, unit fraction, greater than, less than, and fraction in our justification. Okay? All right. Fill in the correct symbol. Let's get a pen ready. I want to label these fractions. I have 1, 2, 3 pieces that are shaded. I have 4, 5 pieces. This is 3/5. On my next one, I have 1, 2, 3, 4 pieces shaded. I have 5 pieces total, 4/5. So what I notice first of all is that these fractions have the same denominator. Okay, there's a connection with those denominators. They're the same. So all I have to think about is which one has more pieces. Well, I have 3 pieces or 4 pieces. 4 pieces is more than 3 of the same size pieces. So this would read 3/5 is less than 4/5. Okay. We're going to use that vocabulary box over here to help us with our explanation. The more vocabulary we use, the happier I am. Okay? Actually, the more vocabulary that you use, the more you show your understanding. It's not about making your teacher happy. It's about growing your brain and showing your knowledge. Okay? So show me that your brain is grown. So let's write a justification here. When the, and look over there, denominators, when the denominators are the same, I'm typing, you're typing. We compare which numerator, another vocab word, makes the greater fraction. So when the denominators are the same, that numerator is in charge. Look at all these vocab words I used. Denominator, numerator, greater, fraction, compare. That's tons of vocabulary in my explanation. I did not say because it's bigger. If you send me information that says because it's bigger, I am going to send it back to you because you did not follow the directions. Are we all clear on that?
Are you going to
bigger,
delete it?
it's bigger, it's smaller is not an answer choice. Okay? Vocabulary is what I need to see. I need to know that you understand what those vocabulary words mean. And I can't know that unless you show me. Okay? Terrence,
Are you going to delete it?
I just told you what I was going to do, which is send it back to you. I only delete work that is turned in completely blank. Okay? All right. These are example slides of what you are going to do today. You are going to notice connections between numerators and denominators. You are going to sort fractions into categories of same numerator and same denominator. And you are going to compare fractions and justify them with vocabulary. Okay? This is your assignment for today. Let's take a look at your directions for your work. Go to slide 7. Slide 7 says, make sure you watch the instructions. Fill in the correct comparison and symbol. Oop, comparison is spelled wrong. Take a look at that mistake. I'm going to fix it. Unlock comparison. There we go. Comparison symbol. Justify your answer using the vocabulary. Okay. So this tells you that there are directions on each slide. This is a sort, exactly the same as we just did with different fractions. And then slides 9, 10, and 11, and 12 are exactly what we just did together. You're going to compare the fraction, write a justification with the vocabulary words that are listed for you. Any questions on that? Okay. This practice is going to help you get quicker at your mental math. With these fractions, you have one of two things. Either the denominators are the same or the numerators are the same. And that should help you be able to quickly determine which symbol you will use based on what you know about denominators and numerators. Okay, so this should be quick for you by the time you get there. If you still need practice, you can use that link to build a model and see. Okay, slide 14, like always, success criteria with vocabulary. All right, I want all of you to look at me right now, and I want a thumbs up or a thumbs down. Thumbs up means you understand, and Miss Sousa, I'm going to do it. Thumbs down means I have questions. Do you understand that you must use these vocabulary words in your justification? Thumbs up if yes, I understand it and I got you. Thumbs down if no, I don't know what those vocabulary words are. Show me with your thumb. Justin, I need you. Oscar, do you understand? Okay. Aiden G, Frank, I need to see your thumbs. Do you understand or do you not understand that you must have vocabulary in your justification? Okay. Aiden G, thumb please. Up or down? You understand? Okay. Frank, Aiden Hampton, and Oscar, I want you to hang out with me so we can get those questions answered for you. Okay. Frank, Oscar, and Aiden Hampton, hang out with me. Okay. All right, people, that is your work. This is what needs to be completed today. Okay, needs to be completed today.